So today we're going to be focusing on multiplying and dividing exponents. I'll show you guys a couple of different examples. Make sure you guys are writing this in your composition book or notebooks, and then at the end, please write down any questions that you have. So on the screen, you'll see the first basic rule for multiplying exponents. For any non-zero value of b and any integer values of m and n, you basically add them. What that is saying is, for example, if you have x squared, that's the exponential form. To expand that would be x times x. However, what we know is that if we have two of the same bases, x squared times x to the third, we can actually rewrite it as x times x times x times x times x. We can actually rewrite the base as x, and then we are being multiplied 5 times. So the rule is basically saying that if you have the same bases with integers in your exponents, you add them. Another example of that would be v to the second times v to the fifth would be saying same base, v to the seventh. If you're not too sure about it, you can definitely expand it out, but it is because we are multiplying that allows us to have this rule. Now, the same rule doesn't apply for adding and subtracting exponents. If you're adding and subtracting exponents, that's a different rule. It deals with similar terms, with coefficients. But today we're just going to be focusing on multiplying and dividing exponents. Okay. So here are some examples that I have. I have 2 squared times 2 to the fifth. Well, there's 2 squared. There's 2 to the fifth. My final solution is 2 to the seventh. This one, the next one, 2a to the third times 3a to the eighth. Now, the same rules apply here. You're multiplying your coefficient first, so 2 times 3 would be 6. And then a to the third, and then times a to the eighth would be a to the 11th. Notice how that in this example, I can only expand the exponents. I'm not expanding 2 times 2 times 2. That doesn't work. Times 3 times a, 8 times. Okay, 1, 2, 3, 4, 5, 6, 7, 8. And what I have left is 6 and then a to the 11th. The next one, I have b to the 6th times b to the negative 4th. We'll get into negative exponents in the next section, but b to the 6th times b to the 4th, they are the same basis, so they're both integers, 6 and negative 4, so I'm going to add them, and b to the second power. Okay, and that's when you're multiplying exponents with the same base. Next, we have something called the power properties of exponents. We call it kind of like the re-raising. Okay, you have bm, b to the nth power, that whole thing to the nth power. You would multiply the two. So an example of this would be, this is saying x squared to the third power. I'm going to expand that. X squared, that's only 1. Multiply by itself 3 times. And then from there, if we wanted to, we can go back to the previous rule I just showed you and expand each of these. And I get 1, 2, 3, 4, 5, 6. That is equal x to the 6. But the shortcut is, if you notice that you have an exponent and then another exponent on the outside of the parentheses, you just multiply the two together. 2 plus 2 plus 2 is 6, or you can do 2 times 3 is 6. Okay, either way would work. Same thing with this one. This one deals with this second rule right here. If you have 2, which is my coefficient of 2, w to the third power times raised to the fourth power, you can write it out 4 times. There's one group. There's 2 groups. There's 3 groups. And there's the 4th group. And just like we did before, I would multiply my coefficients. 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. And then if you really wanted to, you can write out each w 3 times here and here and here and here. Or, since I'm multiplying my w's with the same basis, I just add them. 3 plus 3 is 6, 9, 12. W is being multiplied 12 times. But the rule says that if you know that you're multiplying here, technically speaking, you can break it up. You can go 2 to the 4th power times w to the 3rd power 4 times. Well, 2 to the 4th power is 16. W to the 3rd raised to the 4th power would be, you multiply those together, and you get w to the 12th. Either way works. Okay, so a little bit more expanded from this, but the shortcut would be you would apply the exponents to the number first, and then you would multiply your integers in the second part.